Dividing whole numbers by decimals. Learning goal. I can explain how to divide a whole number by a decimal. Choose a whole number for the blank to make this sentence true. Draw a picture to show why your choice makes sense. Let's start with the first one. We've got some number divided by 0.4 is going to be equal to 5. My approach whenever I have this type of problem is I'm going to turn it around into a multiplication problem. So I'm going to say 5 times 0.4 is equal to the missing number. So 5 times 0.4 is 2.0. Remember, we multiply the 5 times the 4, we ignore the decimal place for the moment, and then once we've calculated, obviously 5 times 4 is 20, then we put the decimal place back in. So we could say 2 divided by 0.4 is 5, or close to 5. In this case, it's actually 5. Exactly. We can use the same approach with the next question. Some number divided by 1.3 is 5 or close to 5. So that means 5 times 1.3 is going to equal to that number that we're looking for. So 5 times 1.3, 3 times 5 is 15, carry the 1, 1 5 is 5, plus 1 gives us 6. We have just one decimal place, so our answer is 6.5. Now with this question, we're also asked to draw a picture to show why our choice makes sense. So for part A, I've drawn a shape here and divided into two, so I have two pieces. And we can see then if I take that whole space and divide it up into 0.4 segments, we'll see how that shakes out. So first of all, I'm just going to put a little notch here to indicate that that would be kind of the halfway point in each one. So that would be 0.5. Now I want 0.4, so I'm going to have a divider there. And then another 0.4 would put it up to about here. And then 0.4 from there would take me over to about here. And then 0.4 again, about there. So I've got 1, 2, 3, 4, 5 segments that are each 0.4 in length. So there's a 0.4 there, a 0.4 here, 0.4 here, here, and here. So if you take 2 and break it up into 0.4 size bytes, you end up with 5 bytes. Let's see how it looks when we take 6.5 and break it up into 1.3 sized bytes. We've got a diagram here now that is 6.5 in length, and I've broken them up into 1/3 sized bytes. Now that's not exactly what the question was asking because it gave us 1.3, but in fact 1/3 is equal to 1.333 repeating, so it goes on forever. So as a result, this isn't going to be exactly correct, but it'll give us a pretty close estimation of what it should be visually. So now we're going to take this 6.5 length that we've got and break it up into 1.3 or 1 1/3 size segments. So here is our first 1 1/3 segment. Then here is our next 1 1/3 segment, and so on. And then this last segment isn't quite 1 1/3, so that's where this error has come in for us. But you can see then that we've got 1, 2, 3, 4, 5 segments that are approximately 1 1/3 in length. So our diagram helps us get a good idea that the numbers that we've calculated make sense. Choose a whole number for the blank to make the sentence true and explain why your choice makes sense. So we've got some number divided by 0.2 is 125 or close to 125. So again, I'm going to turn it around and say 125 times 0.2 is going to be equal to that number that I'm looking for. I'll do my 0.2 in the traditional format that we're used to. 2 times 5 is 10, 1 to carry. 2 times 2 is 4, plus 1 is 5, and then 2 times 1 is 2. We've got one decimal place, so we put the decimal in its place, and we see that 125 times 0.2 is 25. And that makes sense if you think 0.2 is equal to 2 over 10, which is also can be reduced down to 1 over 5. So we're saying that we've got 125. We want to know that if we broke it up into 5 pieces, how big would each piece be? And we can think 125, if you think in terms of money, 25-cent piece. If you had 5 25-cent pieces, you'd have $1.25. So therefore you can think that 5.25 is 125 cents. So it all makes sense. When I look at this question, I see 12 divided by some number, and then the outcome, the answer that we get, is actually bigger, right? The 25 is bigger than the 12. So that means obviously the number that I'm dividing by has to be a decimal, has to be less than 1. Now when I look at these two numbers, 12 and 25, my first thought is that, well, 12 times 2 is equal to 24, and that's pretty close to 25. Now here I'm doing the opposite operation, so I'm dividing by a decimal. So I'm going to use this knowledge of 2 times 12 and think in terms of, well, if I'm multiplied by 2 gets me to 24, that means dividing by a half should get me to the same place. So 12 divided by 1/2 is equal to 24. So do I want to check that to make sure it's true? Well, that's the same as saying 12 divided by 0.5 is equal to 24. Or it's also the same as saying 1/2 times 24 is equal to 12. And I think you'd agree that if you take 24 and cut it in half, you end up with 12. So that gives us a pretty good basis to say that the answer here could be 0.5 or very close to that, because 0.5 gets us to 24, which I would say is fairly close to 25. 175 divided by some decimal is a little less than 500. So I'm going to use that same approach and say, well, 175 times what number will get me to 500, or get me close to 500? I'd start maybe guessing 2. So what's 2 times 175? Well, 2 times 75, just multiply 2 times that, is 150. And then 2 times 100 is 200. So that would give me 350. That's a little bit low, so that's not quite where we want to be. What about 3 times 175? I can take that 350 and add 175. So if I add 175 to 350, unfortunately, I end up at 525. We want to end up with something that's a little bit less than 500. So if 175 times 2 gave me 350, and 3 times 175 gave me 525, that also tells me then that 175 divided by 1/2 is equal to 350, and 175 divided by 1/3 is equal to 525. Where I want to end up, however, is in between those numbers. So that means I need a number, in this case it'll be a decimal, that falls in between those. So remember, the 1/2 is 0.5, and the 1/3 is 0.333 repeating. So we're going to want something that's a little bit bigger than 0.33 and smaller than 0.55. If you look where it falls, we just want to be a little below 500, so it's much closer to the third than it is to the half. So I might say, well, I'm going to try 0.4. So what happens if I do 175 divided by 0.4? Well, if you remember, this is kind of awkward when we have a decimal here. So we're going to multiply both parts by 10. So we end up with 1,750 divided by 4. We can go ahead and do the long division for that. 4 times 4 is 16. Subtract the 16 from 17. Gives us one remainder, 15. When we bring down the 5. 3 times 4 is 12. 15 minus 12 is 3. Bring down the 0. 4 times 7 is 28. 2 left over. Now we're going to put in a decimal and add another 0 so we can bring that down. 4 into 20 is 5. So if we had done 175 divided by 0.4, we would end up with 437.5. So that's not, I'm not sure that meets the definition of being a little bit less than 500. So I'm going to backtrack and take another guess. And this time I'm going to say, well, I again want something that is a bit smaller than 0.4, but bigger than 0.33. So how about a try 0.35? Instead of doing 0.35 to get rid of the decimal, this time I'm going to need to add 2 zeros because we're moving the decimal place 2 places. So I add 2 more zeros to the other side. Now I can go ahead and divide that out. 35 into 175. I'm going to take a guess. If I've got 30 times 5, that would be 150. So that sounds like I'm kind of in the right ballpark. So let's say 5 times 5 is 25. 2 to carry. 3 times 5 is 15 plus 2 is 17. 0 remainder. And obviously, no matter how many zeros I bring down, it continues to be 0 remainder, so it's 0, 0. So 175 divided by 0.35 is exactly equal to 500. Calculate 200 divided by 0.1 and 200 divided by 0.4 and compare the results of your calculations. What conclusions can you draw? 200 divided by 0.1 is the same as saying 200 divided by 1/10. But dividing by 1/10, I remember, is the same as saying 200 times 10. So that's very easy math to do then. 200 times 10 is simply 2,000. Now we'll look at the second part of the question. 200 divided by 0.4. So the thing we notice here is that the 0.4 is 4 times the size of the 0.1 in the previous equation. Let's take a moment and step back and say, remember what happens if you take 200 cookies and divide it by 10 people. Each person gets 20 cookies. If you take that same 200 cookies and divide it by 40 people, so dividing it by 4 times as many, how many cookies are you going to get? Well, in this case, it's going to go down to 5. And the difference between the 5 and the 20, of course, is a multiplication of 4. It's a factor of 4. So that's the same multiplication factor that we had over here. So when you take a number and you divide it by a larger number, the result you're going to get is smaller. And that still holds true even when we're working with decimals. So in this case, we've got 200 divided by 0.4. It is 4 times bigger. This number is 4 times bigger than that number. So that means that our answer is going to be 1/4 the size, or 4 times smaller, if you think about it that way. So I can actually then say, I can use this information that I've got and say it's going to be 2,000 divided by 4, which will give us 500. Now, if we wanted to do this in long division, just to confirm it, we'd start off with 0.4 being divided by 200. We want to get rid of that decimal place there, so we're going to change our equation to be 2,000 divided by 4. And it's not too hard to see that we do that math. We end up with an answer of 500. So that confirms that the answer that we've got here. So the conclusion we can draw is that as the decimal gets larger, the quotient will get smaller. Calculate 450 divided by 0.6 and 450 divided by 0.2 and compare the results of your calculations. So 450 divided by 0.2, if I did 450 divided by 0.1, I know that I'm going to get the same as 450 times 10, which of course is 4,500 or 4,500. In this case, I want to divide by 0.2 though. What we learned in the last step is that if this is twice as big as this, that means my answer is going to be half as small as what I had here. So what I'm really saying is 4,500 divided by 2. And if you think about it, I can divide 4,000, cut it in half as 2,000, And 500, I've cut that in half, is 250. So my answer would be 2,250. And when you look at this calculation that we've got here, if you think about how we were going to tackle this problem as a long division problem, we would have started off by saying, okay, we've got 450, and we want to divide that by 0.2. In order to do that, though, we always get rid of our decimal and add another 0. So we end up with 4,500 divided by 2, which is exactly what we had specified here. Now let's go to the next step of 450 divided by 0.6. Well, remember that 450 divided by 0.1 was equal to 4,500. This is 6 times bigger than this, so our result here, our quotient, is going to be 1/6 of 4,500. So we need 4,500 divided by 6. We do the long division for that. 7 times 6 is 42. Subtracting, we get 3, bring down the 0. 5 times 6 is 30, with 0 remainder. So 450 divided by 0.6 is 750. Lesson summary. One meaning of division involves asking how many of one number fit into another number. For example, 6 divided by 2 can mean how many 2's fit into 6. 1 divided by 0.25 asked how many sets of 2500ths fit into one whole. If you have a sense of how large 0.25 is, you can see that 4 sets of 0.25 make a whole. You can think of the size of 0.25 in terms of coins, right? We've got 25-cent pieces equal to a loonie. You can also think of the size of 0.25 on a hundredths grid. Here you can see each shaded area of different shade represents 25 of the 100 squares. 4 divided by 0.5 asks how many sets of 5/10ths fit into 4 holes. We know there are 2 sets of 5/10ths in one hole. There are 4 holes, so we can multiply 2 sets of 5/10ths by 4. So 4 times 2 equals 8, so there are 8 sets of 5/10ths in 4 holes. 4 divided by 0.5 is 8. And you can see this on the number line where we're doing half-step jumps. And each half-step jump, if we do 8 of those, it gets us to 4. You can also interpret 4 divided by 0.5 as figuring out what number to multiply 0.5 by to get 4. Since 4 equals 40/10ths and 0.5 equals 5/10ths, the question can also be written as some number times 5 equals 40. Now you're dealing with your times tables and the answer is 8. So 4 divided by 0.5 is equal to 8. You can also interpret 4 divided by 0.5 as asking how large a number is if you know that 4 wholes make up only 0.5 of a share of that number. 5/10ths is the same as 1/2, so if 4 wholes makes up 1/2 of the number, then the number must be 2 times that amount, which is 8 wholes. 4 divided by 0.5 equals 8. And again, you can see you've got half of the number, and another half gets you to 8. When you estimate quotients of whole numbers divided by decimals, it helps to think about how many sets of the decimal fits into the whole. For example, to estimate 800 divided by 0.3, you would be estimating how many sets of 0.3 fit into 800. You might remember that 1/3 is about 0.3, so that means there are about 3 sets of 0.3 in one whole. There are 800 wholes, so there are about 800 times 3 sets of 0.3, which is about 2400. 800 divided by 0.3 is about 2400. The exact answer you might see if you put it into your calculator would be 800 divided by 3 is 2,666.666 repeating. This is somewhat close to 2,400, so the estimate of 2,400 is reasonable. Key terms. Quotient. It's the result of dividing. For example, in the equation 20 divided by 5 equals 4, 4 is the quotient. Your turn.